The chemical equation that I chose was rubidium with a subscript of 2, oxygen plus nitrogen subscript of 2, which is our reactant, and that changes into rubidium plus rubidium, nitrogen, oxygen with a subscript of 3, and that is our product. I had to find the element information for all the elements that are in this chemical equation, so I will explain the element information for rubidium. The atomic number for rubidium is 37. The common isotope for rubidium is 37, is the mass number, and there are 15 neutrons in this isotope of rubidium. The group number rubidium is in is 1. The period number rubidium is in is 5. The family name for rubidium is metal because rubidium is a metal. The electron configuration is shown right next to electron configuration, and the number of valence electrons in rubidium are 1. The number of energy levels are 5 in rubidium. And this is the element information for oxygen, is the element information for nitrogen. The next thing that we had to do was balance the chemical equation that I chose. So I did that, and how I did that was that for the elements on each side, I had to balance the number of elements on each side to make them equal to each other. So that's what I did. The next thing I had to do was find the enthalpy of the reaction. So we have the molecules shown, and we had to find the heat information for each of the molecules that were inside of the chemical reaction, the chemical equation, sorry. So that's what I did. I found this on the internet and also online. Actual enthalpy of the reaction. And here's the abstract equation for a chemical equation. So it's A plus B turns into C plus D. C plus D is the product, A plus B is the reactant. So the formula for this abstract equation, so that we can plug in our variables, our enthalpies, is C plus D minus A minus B. So we will plug in, instead of the formulas, we will plug in the enthalpies for these molecules, not formulas, sorry. And as we plug those in, what we got as a result was the enthalpy of reaction, which is negative 470.9 kilojoules per mole. And since this has a negative enthalpy, this means that this is an exothermic reaction because exothermic reactions release heat. The next thing we have to do is turn the kilojoules into joules, the enthalpy of reaction into joules. So 1 kilojoule equals 1,000 joules, therefore what we have to do is take the enthalpy of the reaction, multiply it by 1,000, and we will get negative 470,900 joules. What we now have to do is find out how much heat will be released if 250 moles of our product from the chemical equation was created. And this is for the balanced chemical equation, by the way. So, we would multiply 250 moles times negative 470,900 joules per mole, since that was our enthalpy of the reaction. And we got negative 117,725,000 joules. Now we'll be calculating the change of the temperature. So, we know that the equation for finding out how much heat will be released from a chemical reaction is heat equals mass times heat of capacity times change of temperature. So we know that the mass is 250 moles of the product, and in translation that would be 58,255 grams. Our change of temperature is unknown, since that is the variable we need to find out. The initial temperature that we were given was 21 degrees Celsius, which is the water that's surrounding the chemical reaction. And we have the heat, which we figured out, which is negative 117,725,000 joules. And the heat of capacity will be 2.11 joules per grams degrees Celsius, since this will be in the solid state, since it's losing energy, and that much heat which it would most likely be in the solid state. We plug in our given information into the equation, and we end up getting negative 950.1 degrees Celsius as our change of temperature. And that is the final thing that we had to do in this project, and that is the end of this presentation. Thank you for listening, and I hope you have a great day.